to determine. They created an interagency committee, and will be allowed to determine that a species is really not worth it and we can take it out. Hence, it immediately became known as the God Squad. What happened was that the then chairman of the Council of Economic Advisors was a member of the interagency committee and did the obvious. He read the cost-benefit analysis. And after thinking about it for, I think, was a very few minutes, he realized that the benefits of the dam were irrigation, and some number of acres would be irrigated after the dam was built. But on reading it closely, he realized exactly the same number of currently used acres would be drowned under the lake for the dam. So the dam suddenly had no benefits whatsoever. It was going to create 10,000 acres of land and destroy 10,000 acres of land for a net of absolute zero. The other planned benefit of the dam was that a large retirement city would arise magically on its shores. But that was not discussed. It was enough to show that the dam, even 90% finished, no longer had more benefits than costs. And so the interagency committee decided the dam should not be finished. It should be abandoned. And that was because of the economist. So it's tough enough for economists. But that does not take into account the United States Senate, where late one night, literally late one night, the representative from Tennessee stuck in a line in some other bill that said, and the dam shall be finished. No one paid any attention. It was not worth derailing the entire bill in the conference committee with the House. And so Congress just said, forget the ESA for this dam, just finish it. So they finished the dam. It turns out the snail darter was then found in another stream. So the snail darter survived. The dam did indeed drown the Indian ruins, although not the early settler fort. I'm remembering more of the great details. There's significant Indian ruins, and they were left alone and drowned. There's an insignificant settler's fort, and that was lifted out of where the waters would be and saved. This is the tale of America, right? All the way up and down for just plain silliness. And of course, nobody to this day lives in the magnificent town that doesn't exist on the side of the dam. So that's the full story. The development benefit simply never happened. If you're ever in the process of reading these things, and it looks too good to be true, I assure you it's too good to be true. I have another one, which is much simpler. A friend was doing an analysis of a water project in Mexico. Again, it's a dam. It was going to provide irrigation. And the irrigation was going to be used to grow string beans. And indeed, when you multiply the number of string beans times the price of string beans, the project was great. This actually would make a lot of money. And after about 4 weeks of thinking about it, it occurred to him to look up how many green beans were grown in North America, and discovered this project would about triple the amount of green beans grown in North America. And of course, the price would fall like a rock if you ever did that. And indeed, when you started being more sensible about what you could grow there, the project was a dog. So when you look at these projects, it's worth using your common sense. You may not see it at first, but somewhere in them, very often, is an unrealistic assumption. And when you find that unrealistic assumption, and you're in the right position, in this case, it was working for the World Bank, the financing for the project disappears. The project never got built. And so, but for his realizing that there weren't that many string beans in the world, there would be one very useless money-losing dam somewhere in Mexico. There are many, many, many stories like that. Okay, so benefits are benefits to consumers, like willingness to pay. We know about that stuff. And we know about cost to all. We had a story, right, where the benefits from skiing were $25 million. The cost to Disney was $25 million. And the cost to everyone else was $25 million. And so benefit minus cost was a negative number, and you shouldn't build the project. And that was one of the reasons, but by far not the only reason, why the project didn't get built. So benefits minus cost is a reasonable thing to maximize and not build the project if it's negative. There are two cases that are worth your thinking about. One case is there's as much money for capital costs as one wants, and there's one or more projects. So that's like the private sector. I can go to Wall Street and raise large amounts of money. I just have to have the projects that pay back. So which project should I undertake? Another very common case is you have a limited amount of money. For instance, you're the state of California. You pass a water bond. Not the most recent one, but the one about 5 before that. And the water bond gives you a fixed amount of money. You have projects you want to do with a water bond. Well, which project should you do? Well, you can't do all the projects even if they pay because you run out of money in your bond. Yep. So there's a limited amount of money. And the two lead to some differences in rules. One is maximize benefit minus cost. So every project has more benefits than cost, you should do. That's the way the private sector operates. Another possibility is you have to maximize benefits minus cost, but the costs are a fixed amount. You can't go over the amount you raised in the bond. Well, pretty clear. Then you should get as much benefits as you can for those costs. And in that case, what are you going to do? You could express it as you're going to get the biggest benefit per unit cost. You could say you're maximizing B over C, or you're maximizing B minus C with C fixed. Two things are exactly the same in this case. So you have a bunch of projects, and each has some B and some C, the I of the projects, and you're looking for which projects to do, and you only have a fixed amount of money, then you want to pick them by the ones that have the biggest benefit per cost. So the actual case was there were many different places where you could fix municipal water systems. So for instance, my street has a slow leak and has forever. If you dig it up, you'll dig a 20-foot deep trench, and then you go patch the pipe, and then you'll put it together again. So how much does it cost to dig the street up and make the patch, and how much water do you save? What's the water worth? You have a benefit to cost ratio. You do that for all the potential ways of saving water, and then you just pick the ones that have the most benefits per cost, and that will give you, after you finish picking all of those, that will give you the most benefits you can get for the limited amount of money you have. So when you see people saying maximize, choose the projects to maximize benefits over costs, then their problem has to be we have a limited amount of money. Then that is the right thing to do. You'll get the best possible answer. If instead you could get money so long as B was bigger than C, wouldn't you just keep getting money until you got all the projects where B is bigger than C? Of course you would. So you do many more projects, presumably. If you could just borrow as much as you want to do the project any C you want, you just keep going until you have no projects left with B bigger than C. So you get very different answers depending on which one is your real case. Here's an example. I have two things, a small dam and a larger dam, right? Small dam, benefits of 20 mil, costs of 10 mil, present net value, you want to subtract one from the other 10 mil, ratio of 2. Yeah, benefits are twice costs. big dam, 35 million, 20 million, PNV of 15, lower benefit cost ratio. Yeah? Let's see. Suppose you have limited funds. Here, suppose you have $100 million. Now you have a choice of 10 of these guys or 5 of those guys. Which is better? You'd rather do 10 of these or 5 of these. You do 10 of these, you get $100 million, right? Do 5 of these, you get $75 million. So you'd rather do 10 of these than 5 of these. On the other hand, suppose that you could build as many of these things as you wanted. Then you just keep building these guys. Every time you build one, you get $15 million. There's no limit. So you get a different answer. Yeah. And then you can think of yet another case. Suppose there's just one canyon, and you wanted to build just one dam. You can't build 2 dams in the same place. Which dam are you going to build? Well, it's written you're building a larger dam. Very often, if you look at the numbers, you'd find it works the other way. You'd find the larger dam would have a lower PNV than the smaller one, because the cost numbers here could be outrageous. So you get 1.5 times rough numbers to benefits. This could not be double. This could be triple. And then you want the little dam. It takes a little bit of thinking. So you have to actually look, what is the case? What's the question being asked? Am I being asked to take a fixed amount of money and build the best I can with it? Here I build 10 little dams. Am I being asked, I got one canyon, I can build either the big or the little dam? Here I build a big dam. I have lots of places to build. No problem finding places to build. I build a lot of big dams on these numbers. Yeah, we know about benefits, right? We know area under demand. And we know that we can do that for marketed or non-marketed goods. The costs on these things, on the other hand, tend to be engineering economic estimates. So you want to build a railroad to LA. What do? You get an engineer, in this case, a Deep Kanafani. And you say, well, what cost me to do it? He says, okay, this isn't too horrible because people build things like this. So I have a railroad that's going from here to there. It has so much elevation change in it. It's going to need so many tunnels, blah, 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 blah. And then the cheap way to do it is go to someone who's recently built a number of them and find out what they cost. What's it cost to build a mile of tunnel? Well, they build tunnels all over Europe all the time. So what does it cost them to build a mile of tunnel? I know how many miles of tunnel are in this route. Okay, I put that number in. I need a train set. Actually, a lot of train sets. Well, what does a train set cost? Again, it's not a terrible problem. You go and you look at someone who buys train sets. What did they recently sell for? What are the ones that the Brits just bought cost? Like 135 mil for their Trans-Thames link, right? So you have lots of examples, and an engineer goes, breaks the project down into little sub-project lists, and then prices out each sub-project lit, yeah, and adds the thing together. And that's where the cost for these things come from. I mean, economists could do that too, but maybe you wouldn't trust our idea of what a reasonable tunnel was. Not sure. What gets left out is you don't get all the costs. I mean, in the case I gave you, they missed the fact they were drowning land. You'd think they would have figured that out. They mixed the drowned Indian villages and the cost of keeping the historical sites. Well, I understand how they lost that one, but the historical sites I don't get. The endangered species, if they're there, is a cost. It may just stop your project cold, but at least you ought to think, if I'm going to build something and I make a tiny amount of money on it, and I extirpate 3 species, is that really worth it? At least you should ask the question, and there's lots of other stuff you could add. So one of the problems for an economist is, which of the costs got missed? That's a question they could legitimately ask us, because we're much more used to saying, oh, okay, they should have gotten that, by the way. We're much more used to saying, well, wait a minute, you've drowned some cultural artifacts. That has some value. I mean, I'll give you a great number, but surely it has some value. It's got to count somehow. You're killing off the snail darter thing. That's got to have some value. And we might go down and find a very large list of them. Oh, we ought to be doing a random sample. Okay. So if it's the snail darter, a fish that had not yet been discovered, it clearly doesn't have a great commercial value. I don't have to worry about what it does to the people who live along the side. It's not like Nile perch. Yeah? So I get a random sample of Americans would be the a potential answer. Too expensive, so we probably do a random sample of people who live within a couple hundred kilometers of the site and assume they get most of the value, whatever it is. And practically, that's what we would do. Right? You could ask every American about how do you feel about the Exxon Valdez. That would be legit, as near as I can tell. People in New York are probably just as unhappy about it as the people in Alaska. But it should be a random sample of the group that logically would have a value for the resource. Again, something only an economist would think about. If you're doing a public project, you have to raise taxes. Do people like taxes? No, people don't like taxes. Do economists like taxes? Well, we're ambivalent. We like the projects, we don't like the taxes. Why don't we like the taxes? Because of the deadweight loss triangles. How big are the deadweight loss triangles? Well, Marty Feldstein's going for 30%. That's probably a pretty high estimate. But if that's right, then you got to take all your costs, since you're financing by taxes, multiplying by 1.3. It's not a small adjustment you would make. I kill a lot of projects, include the cost of taxation. Not usually done. Alternatives, we talked about. Oh, the first line, of course, is worth it. So what do you think the Army Corps of Engineers does? What do they do for a living? What's the Army Corps do for a living? Builds dams, dredges channels, moves dirt, right? If you're 7 years old and male, that would be like the ideal job in the entire universe. You get to build big stuff with big machinery. It's completely irrelevant if anyone wants it. Well, that's what they do for a living. So if they make the plans, am I being too cynical by saying they maximize concrete subject to some constraint that benefits the way they state them have to exceed the costs? I don't think so. If they wrote up a document which you want to trust it. What I do for a living is build dams. I'm going to give you a document which I have written that shows you that my dam has benefits greater than costs. They're shaking their heads. They're not believing me, right? Well, that's why we have OMB. Because they don't build dams, they try to safeguard the federal treasury. And so you have interagency disputes. That's something you might do for a living, hopefully on the OMB side. When do you build a project? Now, later. Well, when I'm talking about a dam, you're going to say, well, yeah, I see there's an option value. If I just leave the dam site alone, it'll still be there for me later. So if benefits and costs are about the same today, why don't we wait a decade? You know, if photovoltaics come in a big way, the price of electricity will fall, and we'll be saved the fuss and bother of building a dam we didn't need. Yeah? So why don't we just wait and see? There's some option value here. We always have the ability to build it. We shouldn't go throwing that away just because today it's a little better to build than not. We could build it later. That's another project. That's the way we usually say it. The way Nordhaus works is exactly the opposite. We have a planet that may have a fire. We could build a fire hose now or later. We always have the ability to build a fire hose. So why are we rushing off to build a fire hose now? Maybe it'll turn out we won't need it. Why don't we just wait another 10 years and see if things work out okay? So the now or later cuts both ways. But the basic economics of it, basic decision theory of it is, if you're going to gain information by waiting, then that's a reason why you might want to wait. Of course, in a planet fire, if you wait, you might put enough CO2 in the atmosphere so you can't reverse it. That's a reason why you might not want to go down that road. But you can at least see the argument for waiting. If I wait 10 years and it turns out the price of photovoltaics comes down to the equivalent of 5 cents a kilowatt hour, this is all going to be nonsense. We're just not going to burn stuff. At that price, forget it. We'll do almost everything off of photovoltaics. So it's not an insane thing to say I ought not be going full speed ahead today, because there's lots of uncertainty that's going to be accumulated. If you actually look at Nordhaus's work, what happens is you ramp it up, because as you get closer to your sort of 90-year horizon, your discounting starts to not be important anymore, and the damages start to overwhelm the costs of avoidance. And so in his stuff, we don't do very much today. There are not a lot of early measures, but if things pan out along, say, the 3-degree line, then somewhere 30, 40 years out, we start getting much more serious. And that would be a standard answer for an economist to give you. Another example of interest rates. So in the nuclear industry, the number you'll see quoted is called an overnight rate. An overnight rate is what it would cost to build the plant if you could do it overnight. Does anyone know of a nuclear power plant that has been built on schedule? Anyone know of one that's been built on schedule? Like, in 2006, we said we'd open it in 2016, and it'll open in 2016. What about the new plants that the French are doing, one in France and one in Finland, which are supposed to be the greatest and latest, and we'll be able to build hundreds of them, and we'll get a lot of cost savings because we'll build them all the same? Are those on schedule? No. Schedule slipped like about by half. What about the costs? Are they where they're supposed to be? No. Right? So if you look and someone says the overnight rate for a plant is whatever number of billion to build the thing, 5.646 billion for a 1,000 megawatt plant, and it takes 10 years to build it, what does that really mean? What do you do to start building a nuclear power plant? It's pretty amazing what you do. I never realized this until I saw a picture. You know what you do? You dig a really deep hole, and you fill it with rock. And every layer you put on a rock, you then go and tamp it down. And I mean a really deep hole. And so before you've done a single thing that you think of as a nuclear power plant, you've buried a huge amount of money in the ground. That money is buried 10 years ago. Interest rates are in the order of 7 to 10%. So the stuff you do at the beginning, the cost of that stuff is more than doubled by the time that plant opens. So an overnight rate is a seriously misleading thing, seriously misleading. It's not like it says 5.4 and it should be some slightly larger number. I'll bet you by the time you open the plant, double, because the things take so long. So you've got to get these interest rates in. If you put the interest rate in, then an awful lot of things that look okay on paper stop looking okay on paper. That's one of the pieces. And you can go through the other costs of nuclear. Anyway, you get to a total cost of something like 6.41 billion, at least that's what we used to think. And then what they do to make it comparable is they create this thing called levelized cost. They say, all right, so I know it costs 6.4 bill to do it. I know how much the fuel costs. I know how much the decommissioning costs. And decommissioning is going to get discounted rates 40 years in the future. So even though $1 billion are going to decommissioning, the present value of that's a much smaller number 40 years in. So you do all of that, and then you ask, what price would I have to sell the electricity for over the 40 years the plant is in operation to break even? And the answer turns out, in these things, an MIT study, turns out to be about 10 cents a kilowatt hour. Natural gas in the same study turns out to be about 7.8. And if you want to see the two of them get even, about $50 a ton for CO2 would level them out. So if nuclear had no problems that were not in the numbers, there were no 3 Mile Islands, there's no problem with nuclear fuel that we don't have a place to put, right? All of that didn't exist, then a $50 carbon tax would drop you into a nuclear world, at least on the numbers that were known at the time. I think if you did this again, given the terrible experience the French have had, the numbers on the nuclear would go up again, and you'd have to get an even higher carbon cost to make it work. And I guess I mentioned the glow-in-the-dark fee at the bottom. You have to put that in too. I don't know if there's much more to say about nukes. The key thing here for us, of course, is nukes are huge upfront investment and benefits over a very long period of time. Again, very sensitive to what you do with the time cost of money, whether you think it's a good or a bad idea. All right, so why do we do this? Benefit cost analysis is a screen. It's a way to get rid of truly terrible projects. And that's a good thing to do. Right? You don't want to do terrible. You want to do terrible projects? No, you don't want to do terrible projects. So you don't want to do a project that has obvious benefits less than the obvious costs. That seems like a bad idea. If you're an environmentalist working for the United States, you go work for